Hello, everybody. So today we're going to continue with lesson 6.5, finding common denominators and equivalent fractions. We're on page 269 of the fifth grade Go Math textbook. And the essential question you should be able to answer by at the end of the lesson is, how can you rewrite a pair of fractions so that they have a common denominator? So let's look at the unlock the problem. So Sarah planted two 1-acre gardens. One had 3 sections of flowers, and the other had 4 sections of flowers. She plans to divide both gardens into more sections so that they have the same number of equal sized sections. How many sections will each garden have? So, in other words, she has one section that's in fourths and one that is in thirds. So, we can use common denominators or a common multiple of 2 or more denominators to write fractions that name the same part of a whole. So multiply the denominators. So here we have thirds and here we have fourths. Well, if we take this third and multiply it by fourths, we would have 12 sections. If we took this fourths and broke it into multiply it by thirds, we would again have twelfths. So a common denominator of 1/3 and 1/4, if you just multiply 3 times 4, we'd have a common denominator of 12. So 1/3 times 4, right? We multiplied the 1/3 by 4. We would get 4/12. If we take 1/4 and multiply it by thirds, we would get 3/12. So both gardens will have 12 sections. Okay, so that's one way. Just multiply the denominators. Another way is we can make a list of multiples. And so we would list 3 and 4, and then we would just start making a list of it. And they're suggesting using the first 8 non-zero multiples of 3 and 4. So 3, 6, 9, 12. You know the multiples are just counting by that number. 15, 18, 21, 24. Sometimes we have to extend the list, but usually we can find a common denominator by listing the first 8. So 4, 8, 12, 16, 20, 24, 28, 32. Now circle the common multiples. Well, 12s are in common. 24 is in common. Okay. And so use one of those common multiples as the common denominator. So let's see. Let's say I wanted to use 24 as the common denominator. Because all I have to do is have a common denominator. So 1/3, that was the 1, 2, 3, 4, 5, 6, 7, 8th multiple of 3. So 3 times 8 will give me 24ths. 8 times 1 is 8. The 1/4, I would have to multiply by 1, 2, 3. I'm sorry. 1, 2, 3, 4, 5, 6 multiples of 4 to get 24. So 1 times 6 is 6, and 6 times 4 is 24. So looking at this, both gardens can have 12 or 24 sections. All right, so make a list of the multiples. This is another method for finding common denominators. Now, often it'll be recommended that we find the least common denominator. Okay, and so find the least common denominator of 2 or more fractions by finding the least common multiple of 2 or more numbers. So it's basically finding the list But in this case, we're not just going to circle any common multiples. We're going to find the one that is the smallest that is in common. So use a list. Find the least common denominator of 3/4 and 1/6. Use the least common denominator to write an equivalent fraction for each fraction. So list non-zero multiples of the denominators and find the least common multiples. So multiples of 4. 4, 8, 12, 16, 20, 24, 28, 32. Multiples of 6. 6, 12, 18, 24, 30, 36, 42, 48. Okay, now we're going to find the smallest number that's in common to both multiples, both numbers. 4 and 6, not in common. 8, not in common to anything. 12. 12 is in common to both. So, the least common denominator of 3/4 and 1/6 is 12. Now, you'll notice that 24 is also in common, but we want the least common multiple. The smallest multiple in common is 12. All right. Now, we can use the least common denominator to write an equivalent fraction. So here we have 3/4, and we want to turn it into 12ths because we said that 12ths is a common denominator. So what would I have to multiply 4 by to get 12ths? I'd have to multiply it by 3, right? 4 times 3 is 12. So whatever I do to the denominator, I also have to do to the numerator. So I'm going to multiply 3/4 by 3/3. And that's going to give me 9/12. Then I would do the same thing for 1/6. I'm also going to make 6 into 12ths. So we have common denominators. And what do I have to multiply 6ths by to get 12ths? I'd have to multiply by 2. And again, whatever I do to the denominator, I'll need to do to the numerator. So I'm going to multiply 1/6 by 2 halves. And 2 times 1 is 2, and 2 times 6 is 12. So now you notice that we have common denominators. Well, now if we were asked to add them or subtract them, we could just add them because we found common denominators. So 3/4 can be really written as 9/12, and 1/6 can be written as 2/12. All right, the final method that you're going to learn is using prime factors. And so when we look at 5/8 and 7/20, we're going to use the prime factors of those two numbers to find the least common denominator. All right, so I have 8 and I have 20. Okay, use prime factorization, and 2 times 4 is 8. 2 is prime, but 4 is not. So, all right, so we're going to write 8 as 2 times 2 times 2. And we see that right here, 2 times 2 times 2. 20, I can have 4 times 5. 4 is not prime because I can multiply 2 times 2 to get 4. 5 is prime. So the prime factorization of 20 is 2 times 2 times 5. So now, the common denominator of 5 and 8, you're going to find all the prime factors that are unique in these two numbers. So in other words, there are 3 2's in 8 as prime factors, and there's 2 2's in 20. Well, we're going to use the 3 2's. We're not going to use 5 2's, okay? Because these 2 2's are already accounted for in the 3 2's from 8. So we're going to write 3 2's, and we're going to multiply that by 5. So 2, 4, 8, 8 times 5 is 40. All right, so what do we have to multiply 5/8 by to get 40? 5, right? And 5 times 5 is 25. And how do we turn 7/20ths into 40ths? We multiply the 20ths by 2 and multiply the 7 by 2. And we get 14 40ths. So 5/8 can be rewritten as 25 40ths, and 7/20ths can be rewritten as 14 40ths. Okay. So let's go ahead and practice some. Page 271. So use a common denominator to write an equivalent fraction for each fraction. All right, so 3 and 5. It doesn't say the least common. I just need a common denominator. So let's look at those. 3 times 5, 15. So common denominator is 15. 1/3 times what would give me 15ths? 5. Okay, so 1 times 5 is 5. 3 times 5 is 15. So 5/15ths and 1/5. What would I have to multiply 5 1/5 by to get 15ths? 3. And 3 times 1 is 3. So the common denominator, the equivalent fractions are 5/15ths and 3/15ths. Right? 2/5 and 3/9. Okay, again, it just says find a common denominator. So 3 times 9. 3 times 9 is 27. What do I have to multiply thirds by to get 27ths? 9. And 9 times 2 is 18. So I can rewrite 2/3 as 18 27ths. 5/9, I'd have to multiply 9ths by thirds to get 27ths, and 5 times 3 is 15. So a common denominator is 27. Now these are possible answers, right? I could also say a common denominator of these two is 30. I could say a common denominator of these, of thirds and ninths, is ninths. Because if I made a list, I'd go 3, 6, 9. Well, so that means 3 times 3 is 9. Okay, 2/9 and 1/15. Okay, and we're just looking for a common denominator. So this time I'm going to go ahead and make a list. I could just multiply them still. Okay, again, we're just trying to find a common denominator. So 9, 18, 27, 36, 45, 54, 63. Okay, and 15. 15 times 1 is 15. 15 times 2 is 30. 15 times 3 is 45. 15 times 4 is 60. 15 times 5 is 75. 15 times 6 is 90. 15 times 7 is 105. And we can stop there because I have found a common denominator. I see that both of these numbers have 45. So I'm going to say a common denominator is 45. 2/9 times what will give me 45ths? Well, 1, 2, 3, 4, 5. 5 multiples of 9 is 45. 5 times 2 is 10. So I can rewrite 2/9 as 10 45ths. And 1/15, I can multiply that by 3. 1, 2, 3. And rewrite 1/15 as 3 45ths. All right, number 4, we're going to use a scratch piece of paper and we're going to rewrite numbers 4 through 7, and we're going to find the least common denominator. So we have 5/9 and 4/15. All right, so let's take the denominators 9 and 15. Well, you know what? We actually just did 9 and 15. And so I could take a shortcut and just say it's 45. Okay. But I'm going to go ahead and make the list because we're practicing here. 15, 30, 45, 60, 75, 90, 105, 120. All right, now I'm looking for the smallest multiple in common. 9's not in common to both. 18's not in common. So you just keep going, right? 9, 18, 27. I don't see that. 36. I don't see that. 45. I do see 45. Okay. So the least common denominator is 45. So 5 ninths times what would give me 45ths? 9 times 5. And 5 times 5 is 25. And 4/5 times what? 4/15 times what would give me 45ths? 3. And 4 times 3 is 12. So our equivalent fractions are 25 45ths and 12 45ths. Okay, number 6. 1/6 and 4 21sts. Okay, well, let's start with a list. 6, 12, 18, 24, 30, 36, 42, 48. All right, 21. 21 plus 21 is 42. 42 plus 21 is 63. 63 plus 21 is 84. 84 plus 21 is 105. 105 plus 21 is 126. 126 plus 21 is 147. And 147 plus 21 is 168. All right, so now, do we have anything in common in that list? 6, no. 12, no. 18, no. 24, no. 30, no. 36, no. 42. Okay, so I can use common denominator of 42. So 1/6 times what would give me 40 seconds? 1, 2, 3, 4, 5, 6, 7. Right? 6 times 7 is 42. So equivalent fraction for 1/6 is 7 40-seconds. 4 times what would give me 42s? Well, 2 times 2 is 42. So multiply both of these by 2 halves. And 4 times 2 is 8. So the equivalent fractions are 7 40-seconds and 8 40-seconds. And number 6, we have 5 14ths and 8 40-seconds. Okay, I'm going to use the prime factor method. 14 is made up of 2 times 7. Those are both prime, right? So the prime factors of 14 are 2 times 7. And 42. Well, I know 2 times 21 is 42. 2 is prime. And 21 is made up of 3 times 7. So the prime factors of 42 are 2 times 3 times 7. All right, so both of these have 1, 2. I'm going to use only one of the 2's. There's a 3, and 2 of them have 7's, so I'm going to use 1 7. So the least common denominator of 42 and 14 is 2 times 3 is 6, and 6 times 7 is 42. All right, so 5 14ths times what would give me 40 seconds? Okay, in other words, we're using the 2, 3, and the 7 And we're not going to duplicate the 2 because it's already here, and we're not going to duplicate the 7 because it's already here. Okay? So in a sense, eliminate any factors that are in common to both numbers. Or eliminate one set of the factors that is in common to both. So we're going to use one of the 2s, only one of the 7s, and then the 3 because it's not part of 14. All right, so 14 times what is 42? 3. 3 times 14. And 5 times 3 is 15. And 42 is already, 8 42s is already 42s. So I'm going to rewrite this as 15 40-seconds and keep 8 40-seconds. And number 7. 7 twelfths, 5 18ths. Right, I'm going to try prime factorization again. All right, so 12. I'm going to use 2 and 6. Well, 2 is prime. 6 is not. 6 is made up of 2 and 3. So 12 is made up of 2 times 2 times 3. All right, how about 18? Well, let's use 2 and 9 for 18. 2 is prime. 9 is not. 9 is made up of 3 times 3. So the prime factorization of 18 is 2 times 3 times 3. All right, so I see 2 2s here. I'm going to use those 2s. And I see 2 3s here. I'm going to use those 2 3s. Okay, because one of these 3s is already in common to this, and one of the 2s is already in common. So our prime factorization, or our least common denominator would be 2 times 2 times 3 times 3. So 4 times 9, 36. So what do I have to multiply 7 twelfths by to get 36ths? 12, 24, 36, 3. So 7 twelfths is the same as 21 36ths. And 5 18ths, I know I can multiply by 2. 2 halves. 18 times 2 is 36. So 5 times 2 is 10. So we can rewrite these as 21 26ths, 36ths, and 10 36ths. All right. Number 8. Use reasoning in the area of algebra and write the unknown number for each unknown box. So we want the least common denominator for 1/5 and 1/8. Well, if we were 5 is a prime factor, right? And the prime factors of 8 are 2 times 2 times 2. Well, that means I can just multiply those two together. 5 times 8 is 40. So the least common denominator of 8, 1/5, and 1/8 is 40. Okay. The other thing we can use for reasoning is 5 has to end in a 5 or a 0, right? Well, let's look at 8s. When would the first number that ends in a 0 be? So 8, 16, 24, 32, 40. 40. And I know 5 can become 40. So the least common multiple is 40. Because I didn't say 5 when I was counting by 8s. The multiples of 8 times anything has to be an even number. Okay, so it would never end in a 5. All right, 2/5 and something, and the least common denominator is 15ths. Well, the only possibility is 3. 5 times 3 gives us 15. And 3 something and 5 6, and the least common denominator is 42. Well, if I make a list of 6s, 6, 12, 18, 24, 30, 36, 42. So what number could I also use that would give me 42 as the least common denominator? Well, what is 6 times 7? 6 times 7 is 42. 1, 2, 3, 4, 5, 6, 7. So 7 times 6. Number 11. Arnold has 3 pieces of different colored strings that are all the same length. Arnold cut the blue string into 2 equal size lengths. He cut the red string into 3 equal size lengths and the green into 6 equal size lengths. He needs to cut the string so each color has the same number of equal lengths. What is the least number of equal size length of each color string he could have? So basically we have 2 and 3 and 6. So what's the least that he could cut these into? Well, basically we find the least common multiple of these. That would be our answer. So how can we find the least common multiple of 2, 3, and 6? Just by making a list, right? So let's start with 2. 2, 4, 6, 8, 10, 12, 14. Okay, 3. 3, 6, 9, 12, 15, 18, 21. And 6. 6, 12, 18, 24, 30, 36, 42. All right, so do we see a number? What's the smallest number in common to all 3 numbers? Well, 2 isn't, and 4 isn't. 6. 6 is there, and a 6 is there. So the least number would be 6 pieces. Number 12. One tray of granola bars was cut into 4 equal-sized pieces. A second tray was cut into 12 equal-sized pieces, and a third was cut into 8 equal-sized pieces. He wants to continue cutting until all 3 trays have the same number of pieces. How many pieces will there be on each tray? Well, 4, 8, and 12. Okay, this is multiples of 4. 4, 8, 12, 16, 20, 24, 28, 32, 8. 8, 16, 24, 32, 40, 48, 56, 12, 12, 24, 36, 48, 60, 72, 84. All right, which one's in common to all of them? 4 is not. 8 is in common to 8, but not 12. 12 is in common to 12, but not 8. 16, no, 12 is not 16. 20, no. 24. Okay, I do see 24 in all 3 lists. So 24 pieces on each tray. Okay, again, so we found that by just making a list of the least common multiples of all 3 numbers. All right, and number 13. Katie made 2 pies for the bake sale. One was cut into 3 equal slices and the other into 5 equal slices. She will continue to cut the pie so each one has the same number of equal sized pieces. What is the least number of equal sized pieces or slices each pie could have? What information are you given? Well, we're given that one pie has been cut into 3 slices. A second pie has been cut into 5 equal slices. What problem are you asked to solve? What is the least number What is the least number of equal sized slices each pie could have? All right, so C. When Katie cuts the pies more, can she cut each pie the same number of times and have all the slices the same size? Well, no. Because let's say she cuts this pie 5 more times, or times 5. That would be 15 equal slices, right? But this one, let's say we're going to make that times 3. These cuts would be smaller. I mean, these cuts would be bigger than these cuts. So, no. All right, one pie is cut into thirds, the other is into fifths. So that means she's going to have to cut the first pie, the one that's cut into thirds, more times than the one that's cut into seconds. Uh, More than the second pie, which is cut into fifths. So how can we do that? Well, we know 3 is prime and 5 is prime. So just multiply them together. 3 times 5, so the least common denominator is going to be 15. So if she takes this first pie, how is she going to turn it into 15 slices? Well, she'd have to take each slice and cut it into 5 separate pieces, right? So 2, 3, 4, 5. And each of them would be cut into 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now we have 15 pieces here. This 1/5, in order to get 15, we'd have to break each of them into 3 slices. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. And we still have 15. So she's going to cut the first pie. And each of the second ones into thirds. So each slice is going to be 1/15 of the whole pie. And 14. Mindy bought 5/8 pound of almonds and 3/4 pound of walnuts. Select a pair of fractions that are equivalent to the amount that Mindy bought. So let's look at eighths and fourths. 4, 8, 12, 16, 20, 24, 28, 32. 8, 8, 16, 24, 32, 40, 48, 56, 64. All right, so 5/8 can 3/4 become 6/8. Well, when I look at the fourths, I do see eighths. So what would I have to multiply 3/4 by to get eighths? Well, that would be 2 over 2. So that would be 6/8. Yes, that would be true. 16ths. Well, 16ths are in common to both, so let's see if that's possible. 5/8 times what is 16ths? 2. 8 times 2 is 16, and 5 times 2 is 10. So that would work, 10/16. But how about the other one? 3/4 times what is 16ths? 3 times 4 over 4, right? 4 times 3 is 12. So no, not 14/16. It should have been 12/16. So not B. 30 seconds. I do see that they could both become 30 seconds. So let's see. 5/8 times what is 30 seconds? 8 times 4. 5 times 4 is 20. So that does work. Let's see the other one. 3/4 times what gives us 30 seconds? 8. 8 times 3 is 24. So no, it should have been 24 30 seconds, not 23 30 seconds. And the last one, 15 24ths and 18 24ths. So 5/8 times what equals 24ths? 3. 3 times 5 is 15, so that checks. Now let's try 3/4. 4 times what is 24? 6. So 3 times 6 is 18. Yes, those are equivalent fractions. All right, so that's it for finding common denominators using equivalent fractions. And in our next lesson, we're going to take that skill and we're going to add and subtract fractions. So until then, I will see you soon.